In this video, we're going to talk about parameters and scope. So what are parameters? Parameters are values that are passed into a method. Now, if you recall from the last video, a method can be a procedure or a function. Okay? There's two ways that we can send values into a method. Now, the actual syntax of how we do this is going to be a specific video or videos in each of my language series because it varies. But the basic methodologies of how we pass parameters into methods are the same. And that is either pass by copy, and we'll talk about the other one in a minute, but pass by copy is where we are passing by value, the value assigned to the function's formal parameter variable. In other words, when we set up a function or a procedure, we're going to have variables inside those parentheses when we define the method, whether it's a function or a procedure, and this could be function or procedure. But the variables that are inside that parentheses in what's called the signature of that method are where we're going to pass a value of the external value that we want to go in. So if I'm passing the value of x into a method and I'm using pass by copy, if x equals 5, I'm not passing the variable, I'm passing the value 5 into this internal variable. So if I have a method called, let's say it's a function called add, and in my header I have int x and int y. Okay, and I have a value out here called a equals 5, b equals 5, and I'm passing a and b into add. So I'm saying add a comma b. So I'm passing a 5 and 5. So those 5s, the value 5, is what's passed in, not the actual variable itself. Because remember, a variable is a token that points to a memory location. So in pass by copy, I'm going to the variable and finding the value in memory, and I'm copying that value and passing it into the method. Okay, so it's by copy. I think of it as I'm making a photocopy of the value of that variable and sticking that in. I can't change the outside variable because that outside variable is out of scope. It literally does not exist inside this method. Okay? So, and that's where we get the scope. So when I'm inside this method, I've passed in a copy of that value. Now there are times where a language either won't or doesn't know how to send a custom object in. Okay, if I'm dealing with a class or a struct and I'm trying to pass that in, it doesn't know how. So that's going to then go to what's called pass by reference. Now pass by reference means I'm passing in the memory location of that variable where you can go get the value on your own. Okay, so I'm giving literally memory access to that variable. So now if I change it in here, it is going to change the outside variable. Okay, because I'm literally looking at the same point of memory. I didn't copy in a value. I literally gave you the keys to the kingdom, right? I let you in the vault. I let you have the memory address of where that variable is. So if you change that variable now, right, and we'll get that into that with the formal parameter headings of the tokens where the two tokens are pointing to the same place, you can change that external variable and affect my code. Okay? And there's some slight differences when we get into the Java course because Java doesn't technically use pass by reference. They use what's called pass by reference copy. That's for another day. But I want you to understand that pass by reference is we're passing in the memory location. In the language C or C++, we're literally passing in the pointer. Okay, we're passing in the memory pointer so that you can do damage on the outside now, because you've effectively brought that variable into scope. You haven't brought that variable itself into scope, but you've created another variable that has a pointer to the same place in memory. Okay, so that you're passing by reference. All right, now scope. Variables defined inside a block do not exist outside that block. Okay, the scope of a variable is where it exists. And the reason scope is important is it's the beginnings of encapsulation, where you can protect variables. You can't just reach into my classes and modify them unless we're in the sloppy language called Python. But in languages like Java and C# that enforce encapsulation, the scope of a variable is very important. The scope of the variable also affects garbage collecting and memory management. Because if I'm going to create a bunch of temporary variables in this little routine, I may call this routine a lot, but it may be a memory hog. And so the minute I'm done with this, I want all those variables to be reusable, so I free up that memory until I need it again. You know, I may call it a lot, but I may only call it once an hour. And I don't want to log that, I don't want to have that memory clogged till the next time I use it. Okay, so when in a block of code, anything that I've defined in that block only exists in that block. Okay, that's why a method, which is a named block of code, if I need values in there, I have to pass them in. And there are sometimes I need to get that result out. And so that result has to come as a return value, right? So that when this is gone away with, I still have the returned result. That's why you need to store that result in a variable. Okay, and that's the definition of a function. If I just say go do this code, then all those variables I use are thrown away. Fine, at least the code got executed. But if I need a value back, then it becomes a function, because I'm going to calculate some value and return that value. Okay, and the system will track how that value comes back. So these blocks of code with the variables I create in those variables are local in scope to that block of code. Okay, so I need to design my variables so that I only need them when I need them. Okay, I want to be able to throw away variables that are out of scope as much as possible, to use as little memory and to be as efficient as possible. So, block internal variables, garbage collected when they're no longer needed. It's a foundational concept to encapsulation, like I've said. And one of the things that I see students want to do is to create globals, where these global variables, they can call them wherever they want because they're defined, out at the beginning of main, and they have global scope, and I'm like, why? And the reason they do it is because it's easy, right? But those variables are hogging memory the entire life of the code, even though you may only use it once. Okay, and it's bad programming design. And it's done in most cases because students don't want to overcome the learning of passing parameters. Parameter passing seems to be something that people get tripped all over. But we're going to unpack it slowly in the language section in C, and then again in Python. And we're really going to take some time to make sure you understand how to do that, because when you move to CSA and do it in Java, it gets just weird enough that you really want to have a good understanding of it to make that easier. So parameters are very, very useful to us. And when you get to the point where you're like, okay, I have a return value, but I want to return 5 values. Now what do I do? Right? Because a return is only going to let you return 1 value. Now you're beginning to ask the questions that as a computer science teacher I get excited about. Because I get to say, all right, you understand you have to pull a value out and return it from a function. But what you really have is 3 values you need to get out. Well, if you're in Python, slap them in a tuple and return the tuple, because the tuple can hold multiple values. If you're in C, and they're all integers, you might put them into an array and return an array where the first value is this one, the second value, right? There's different ways. Some languages allow you to have an out variable in the signature where it creates a variable that you can access externally as another return variable. So there's some weirdities with some of the languages, but the bottom line is when you really begin to understand how to move variables and data in and out of methods, you're really beginning to put the pieces together, because you will suddenly see that your code can become very modular. You can have methods, and whether they're functions or procedures, that do specific things you need over and over again. And when you understand that, you now have enough to begin to build classes, which are recipes for objects, and objects are how the machines will take over, because object-oriented coding is where it's all at, okay? And objects begin to let you see the matrix, where you really become a powerful programmer. When you can create class structures that are instantiated as objects that you can use over and over and over and over again, that can do their own thing, it's really cool. And we're going to start to get into that by the end of this course. That's what CSA is really all about, as far as I'm concerned. I teach both this and the CSA course as programming courses. I don't do any social studies bented, let's explore this and talk about this and write, build dioramas about technology. We're here to program. We're here to turn you guys into world-class programmers from the ground up, so that when you leave here, you've got a good foundation to move into a CS class and show up your freshman year with a little bit of a halo effect. Okay? So, if you get a value back, you're in a function, not a procedure. And what do we do with that value? We store it. Okay? All right, in the next video, we are going to talk about the 3 pillars of every program you will ever write. See you on the other side.